Hi, hope you're doing great. My name is Augustin. I'm a researcher in AI from UC Louvain, and I'm here with my colleague Yanis to present you our project proposal, which is about railway defect detection, and more specifically, we want to build a digital twin for the infrastructure. But more on that later. First, let's give you some background information. So this project is a part of a larger project called the TReC Revision Project, TSV. It's a project funded by the Wallonia region, and it's about developing a low-cost autonomous system for detecting railway defects. One problem that we face in this project is that we need to train our detection model some large and annotated datasets. And it's actually really hard to compile such datasets. It's very costly to do, and most of the time it's not even available. One reason for that is that this kind of data can be quite sensitive, and so infrastructure companies are quite reluctant to share this kind of data with us. And another problem with the open datasets is that most of the time they represent like surface defects. You can see there with the yellow bands, the squats, the spalling, the shellings, basically the cracks in the rails. But they, to the best of our knowledge at least, they do not represent the geometry defects. So when the rail that's supposed to be perfectly parallel like moves a little bit, this can have like really bad consequences, and we do not have data on that. And so, our solution to this problem is to build an open digital twin. So the idea is that we want to model in 3D, like in a 3D software. We want to model the train tracks, the sleepers, the ballast, etc., the whole infrastructure, and we want to inject ourselves some defects and use that as our synthetic data. So the approach is in two parts. First, we want to actually model the rails. We want to use a software called Blender. I guess you guys probably heard of that before. And the second part of the approach is to extract from real photographs of normal looking rails and defectuous rails. We want to extract the texture to like dress the 3D models so that it looks like what real train tracks look like. We want it to be as realistic as possible, of course. So a little bit about ourselves. As I said, my name is Augustin. I work in neurosymbolic AI mostly, and Yanis here works with computer vision, generative AI, and multimodal learning. On this project, we're also accompanied by Tanguy, who's from Umons. He could not be here today, but he's working with visual data processing, among other things. And so what will those 2 weeks in Switzerland will look like with us? The first few days, we want to establish the track geometry. So as I said, we will use Blender. And the idea is that we want not only to model what the normal looking train tracks, but we also want to inject some defects, some deviations with the track alignment, with the sleepers, etc. And we want it to be parametric. And the second part, so the next few days, are about the extraction pipeline. So we want to use some foundation models to isolate the material from the real photographs and build PBR maps. So we want like the texture to be tileable so that it really dresses the models and it interacts with the lighting, etc. More on that, you can come talk to us afterwards. It's a bit complicated. And the last days of the research camp, not workshop, we want to like do the integration of the packaging. So the idea is that we want this to be like a fully functional pipeline. We want you, if you are an infrastructure company, to be able to have like your photographs of your own rail and your parameters about the deviations, etc. And it's a fully functional pipeline. And so who are we looking for? Well, basically anybody who's motivated If you have like used previously Blender, that's a great asset, of course, but that's not mandatory. Again, if you used foundation models such as the segment anything model, it's great also, but not mandatory. I guess the only mandatory thing that we ask is that you have some kind of knowledge of Python, because like the pipeline will be in Python. It's better if you don't have to learn the language. But yeah, voila. Do not hesitate to come talk to us. We'll be really glad to discuss this. And yeah, thank you.
Great, thanks. Any question? Online? No. Just probably I missed it, but talking about 3D modeling, I've heard a lot about Gaussian splatting, triangle splatting, etc. Do you plan to use it or not at all related, and why?
I will take this, since I've worked on splatting. Well, there are approaches of stereo vision modeling, 3D modeling, based on either NERF or Gaussian splatting. This is what you're talking about, right? All of these methods, they require a substantial infrastructure to be implemented, meaning that you need GPU computing power to render them, to fully make them implementable. 4D rendering of these, the 4D version of these architectures is still very much under research. And 4D, I mean, you have the splat, but you have it over time. So you have a video. We are looking for something way more lightweight, to be able to run possibly in real time, to be able to produce results quickly, not too precise, but precise enough for a modeling of the situation. And most likely we're looking for solutions that are easily implementable, and we don't want to over-engineer it with too much of an experimental pipeline. I hope this answers the question.
Yeah, for sure. Great. Thanks. Any other?
I have a question.
Yeah, right.
Yes. For the parametric generation of the in Blender, do you have all the physical constraints?
The parametric configuration of the defects. Did I hear the question right?
Yes.
We have the defects already defined by design. We have them.
I mean for the generation, they have like all the physical constraints of what can be possible within the generation using Blender.
The texture generation or the defect generation?
Defect generation.
The defect generation, we already have them defined, or at least the major use cases that appear on railways. For the textures, there is not too much parameterizable. We do have the basic architecture, the basic approaches that we can apply on these, and we will pursue from there.
Okay. Thanks.
Thank you for the question.
Hassan, another question? Yeah.
Actually, a naive question, but
There are no naive questions.
it looks to me that you are trying to build a simulator and then get some data of it. Can you just put, simply a camera on a train and get data? I don't know.
Well, I only need a train for that. I have the camera.
I mean, if you partner with the SNCB or railway infrastructure or anything, can't you put cameras on top and I don't know.
Yeah, that's a great question, actually. Few problems with that. First of all, yeah, we do not have a train. We do not partner with Infrabel, so it's hard for us to get that. Second of all, the main problem is that actually the project I presented you, the TSB project, is aimed at the global south, such as like African countries. And the railway infrastructure in Europe is of too high quality, if that makes sense. So those defects that we want to detect are actually kind that don't exist here because the railway is too well maintained. I know like it's a bit tragic to say, but that's the case. So voilà.
Thank you very much.